Good day, ladies and gentlemen. My name is Ben, and today we are going to be doing episode 7 of the video series So You Want to Be a MATLAB God. In today's episode, we are going to be covering while loops. So, while loops allow users to run a sequence of code until a certain stopping condition or conditions are met. For example, as we're going to do in today's video, you could do the Newton-Raphson numerical method to find the zero of a function until either a certain error margin is achieved or until a certain number of iterations are run. So we're going to start by making a simple counter in MATLAB with a while loop. And we're going to show you that it is essentially just a for loop. So we're going to start and make a variable called counter, and we're going to say it equals to 0 just to start out. And then to do a while loop, we simply type while. And we're going to say, while counter is less than 10. And then we're going to say in our while loop that counter is equal to counter plus 1. And then, like everything else in MATLAB, we close it off by simply typing end. So if we go and run this, we can see that counter goes up to 10. And now I'm going to actually prove that it does this 10 times. So we're just going to say counter. And as you can see, counter increases by 1 every time. And this is essentially just a for loop. So we can also have multiple stopping conditions for while loops, just like with if statements. And so we're going to keep the counter so we don't run too many iterations. And then we're also going to have a user input now. And we're going to say that user input has to be less than 100. And so we're going to say and the input, and we're going to call it in, and we're going to say it is less than 100. And so we are also going to have to make a new variable called in, and we're going to say it's equal to 1, because that way this is defined here, and that this will actually run and not error. And of course it has to also meet this condition so that it runs the loop. And so now we're going to say in is equal to input, give me a number. So now if we go and run this code, it asks you to give me a number, so I'm going to give it 2, and obviously it doesn't like that, so you give it 3. Now we're going to give it 102. And as you can see, then it stops. And then see our last input was 102. Counter, we got up to 3. We did it 3 times, as you can see here. So just to prove that both conditions have to be met, we're going to just give it bad inputs a whole bunch. And as you can see, it also does 10 iterations and then stops. So that can be very handy if you have multiple conditions that you need to satisfy. So another thing to watch out for when you are doing while loops is that you do not create an infinite loop. So for instance, let's say that we have counter is less than 10, but then we just don't have this and we don't have this, and for some reason we wouldn't say it, and we're going to say f print f, and we're going to say this is an infinite loop, just because we can. So as you can see, both of these are always going to be satisfied, and so this is going to continue to run indefinitely. And so as you can see, MATLAB doesn't really like that, and so we can hit Control-C so we can cancel our running of the code. So this is something you guys need to be careful of when you are using while loops, because otherwise you can have while loops running forever, and obviously you're not going to accomplish anything with that. So now we're going to do a practical example of using while loops to solve a problem. We are going to do the Newton-Raphson method, which is used to find the roots of functions. It can be very commonly used for functions where you cannot explicitly solve for what the root will be. So I'm going to get rid of this code real quick, and we're going to do it for the function f of x is equal to 1 minus x plus sine of x. So as you can see, this is not a function. If you want f of x to equal 0, you cannot explicitly solve for x, and so you would use the Newton-Raphson method. So we're going to define an error margin that is allowable, and we're going to call it E allow, and we're going to say E allow is 0.001, which is a 0.1% error margin. So we're going to start now with an E that is equal to 1, and you'll see that this is to initialize the loop. So now we're going to do while E is greater than the allowable error margin, so that's E is greater than E allow. And then also we want a counter, because if this doesn't converge, we don't want it to just run forever and create an infinite loop. And so we're also going to make a condition with the counter. And so we're going to say and the counter has to be less than 20. So we're going to do this, we're going to hit end, and then we also need to make the counter variable, and so we're going to say counter is equal to 1 just to start it off. And to do Newton-Raphson, we need to first define f of x. And so we're going to say f of x is equal to 1 plus our xi, we'll get to that in a sec, plus sine of xi. This is the exact same equation up here. Xi is going to be whatever our guess of the root is. And so we need to start by putting an initial guess up here. We'll say xi is equal to, we'll say 1 for now. And so also for Newton-Raphson, we need to calculate the derivative of f of x. And doing some very simple calculus, it is simply dfx is equal to minus 1 plus cosine of xi. Oop, and I made a little mistake here. This is actually supposed to be a minus to follow our function we have up here. And so now we need to find the next iteration of our guess. And so we're going to call that xi p1 for xi plus 1. And that is going to be xi minus f of x over d f of x. That's really cool. And then we need to calculate our error for this iteration. And we're going to say E is equal to the absolute value of xi p1 minus xi divided by xi p1. And then, of course, times 100. So now we are going to print a result. And so we're going to print f, and we're going to do some fancy magic with the fprintf tool so we make a nice table. So we're going to say percent 10.0f slash t percent 10.4f slash t percent 10.4f slash t, and then one more, percent 10.4f, and then we're going to hit slash n. And so what this does, we're going to have the counter so we know what iteration we're on. We're going to do xi because that's what our initial guess is, and then we're going to get our next guess, and that's going to be xi p1. And then we're going to have our error at the end. We'll set E. And then, of course, after this is all said and done, our next xi becomes xi is equal to xi p1. That's just to update. And then, of course, because we want our counter to update, we say counter is equal to counter plus 1. And then, of course, so we have an actual, this is going to print out like a table. And we're going to make a little thing at the beginning so the printout actually looks nice. And so we're going to say f print f, and we're going to say Newton, hit the caps lock, Raphson. And then we're going to say /n, and then we're going to say percent 10s /t percent 10s /t percent 10s /t, and then one more percent 10s, and then now we're going to hit /n, and then we're going to hit this, so we have a nice little bar looking thing, and then we're going to hit /n again. So we're going to hit this a few more times, make sure it's big enough, close that, and we're going to say iteration xi plus 1, and then we're going to have error also. So and that's going to be in percent. So let's run this and we're going to see what we find. So we do Newton-Raphson, and as you can see, it only needed to do 5 iterations before the error was in the acceptable margin. So that's really cool. But if we were to say make something that didn't converge, it would just run 20 iterations and then stop. So that is all I have for today's video on while loops. I hope you learned something useful and that you can apply this in your MATLABing endeavors. If you enjoyed, please like, favorite, subscribe, and turn on the notifications so you can get more videos coming to you very shortly. Have a nice day.